All right, this is the last page of the first packet. This is page 6. This is from the 2003 test. It's number 2, calculator is allowed. A particle moves along the x-axis so that its velocity at any time is given by this equation. At time 0, the particle's position is x equals 1. So I'm going to rewrite that as x of 0 equals 1. Part A says find the acceleration of the particle at time 2. Is the speed of the particle increasing at time 2? Why or why not? Okay, so first, find the acceleration at time 2. A of 2 is equal to v prime of 2. Should I bother finding the actual equation for the derivative for v prime? No, I would have to do product rule. Not that I can't do it, but it would be easy to make a mistake. And sorry, I should have said v prime of 2. And if you're allowed to use a calculator, all we're going to have to show is this, v prime of 2. So let's see. So this is split screen. Let me split screen here so I can see it. Gosh, I just put this in a bad spot to drag around here. There we go. All right, I don't want to keep flipping back and forth. So I want to take the derivative. So math 8 with respect to x of this function. So negative x plus 1 sine of x squared over 2. Evaluate it to 2. Yeah, evaluate it to. Double check. You should be in radian mode because we have a trig function, so that matters. And just double check that you typed it in same as they have here. I think I'm good. I'm getting 1.588 if I round to 3 places. You should be rounding to 3 places for the AP exam. And I don't think we have labels here. No. Okay, so first part is done. Find the acceleration, done. Is the speed increasing? So we've had this question a few times now. Speed is increasing if velocity and acceleration have the same sign. So I've shown that a of 2 is positive. I want to find v of 2. What's v of 2 equal to? Again, don't crunch the numbers really. You can just say, okay, v of 2, like don't try to do it by hand, I guess is what I'm saying. V of 2 is going to be negative 2 plus 1 times the sine of 2 squared over 2. Okay, you could probably do some of that math, I suppose. That's negative, right? So negative 2.728. All right, so what do I need to write here? The speed at t equals 2 is, it says, is it increasing? So is decreasing, or you could say, no, the speed is not increasing, is decreasing because a of 2 is greater than 0 and v of 2 is less than 0. They're acting against each other. V is negative, but a is pushing in the positive direction. All right, for part B, find all times in the open interval 0 to 3 when the particle changes direction. When does the position change direction from left to right or vice versa? That's when velocity changes signs. So I'm going to, sometimes I like to write my reason down before I investigate it so I know what I'm looking for. So position is on the x-axis. So x of t changes direction when v of t changes signs. So that's my justification right off the bat. And then does this ever happen? So I don't know, let's graph this thing on the window 0 to 3 and see what it looks like. So I'm going to go to y equals negative x plus 1 times the sine of x squared over 2. I want to change the window 0 to 3, and then I want to zoom fit. So zoom, option 0 is zoom fit. So it looks like the velocity is negative until it hits this point and then changes to positive. So we need to find what that is. Now you can go to second trace and have it find a 0, or I think it's faster to go ahead and type in 0. I like to just find the intersection point here. I think that's faster. It does not matter. The calculator is going to give you the same answer either way, But yeah, enter, enter, enter. I just like that because I don't have to scroll all the way over there, go left and right. So 2.507. So this happens once. Does it say fine all the time? Yes, this happens once at t is approximately equal to 2.507. Okay, my answer is already justified. I led with the justification. I gave the time. Yeah. Part C, find the total distance, absolute value, traveled by the particle from 0 to 3. So remember, putting an absolute value around this, let me just show you this. Math, absolute value of y1. Putting an absolute value around an equation, just see how it just reflects that part, makes it positive. It's the same area, it just makes that area positive. So that's what we're doing mathematically. But for part C, all I'm going to do is say, okay, from 0 to 3, I'm going to take the integral of the absolute value of negative t plus 1 sine t squared over 2 dt and find what that value is. So, all right, now I already have absolute value of y1 here, but I think I'm going to go ahead and type that in again because you probably wouldn't have done that. So math, 9, 0 to 3, absolute value of, my equation is in y1, so let's pretend I didn't do this one. Excuse me. Oh my gosh. So absolute value of y1, alpha trace y1, or type the equation out, whatever. You know I'm a fan of y1. I'm not typing and retyping things. So I'm getting 4.334. That's our total distance. Okay, and then part D. During the time interval 0 to 3, we're including the endpoints, what is the greatest distance between the particle and the origin? Show the work that leads to the answer. So, okay, so the greatest distance between the particle and the origin. So if we think about this, we have a velocity graph, right? The particle is starting at 0, 1, and we're on the interval 0 to 3. So if I go back and look at let's look at our graph again. So the particle starts at 0, 1, and then it decreases until this value. We can figure out what that is. And then it increases a bit. I would say definitely farthest from a greatest distance from the origin. It doesn't matter whether it's positive or negative. It's definitely going to be farthest from where it started, right? Well, it's starting at 1 though. So let's see how far it is at this point, and then let's see how far it is up here. I still think this is probably the answer. But all right, we're basically looking at what are the candidates and what are we going for. So let's do the candidates. Candidates would be t values of the endpoints, so 0 and 3. And then also that little time where it changed over there, 2.507. Let's see what let's see what x of t comes out to. So x of 0 we know is 1. At 3, it would be 1 plus the integral from time 0 to time 3 of v of t dt. So what does that come out to? Where do we land at 3? So 1 plus math, 9, times 0 to time 3. V of t is still in my y equals, right? So I was just double checking on that. So I'm going to put in y1 right here. All right, so that's negative 1.197. And then let's see, where are we at 2.507? Now I did round that. I think that's going to be okay to use that rounded value. I technically probably shouldn't. If I want to get really crazy here, I guess I want to get really crazy here. I want to be as precise as possible. So let's go ahead and let's find this and write down all of its points. So it was really split screen. It was really 2.5066283. So when I integrate this one, it's going to be, okay, start at x of 0, add the integral from 0 to 2.5066283 of v of t dt. And what does that come out to? So, okay. 1 plus, like, I don't think it's going to change my conclusion to round versus not round. So that's why I say it probably doesn't matter. But it's nice to get in the habit of being precise and not using rounded numbers to get other answers that are also going to be rounded. Precision is the key. I'm just double checking that I typed the decimal in right. Yeah, so negative 2.265. We're talking about distance from the origin. So this is definitely further from the origin, farther from the origin, I don't remember, than this one. So determine the time where that's happening, show the work that leads to the answer. So the greatest distance from origin occurs at, what is the greatest distance? Is, now it's a distance, so make it positive, 2.265. I could say like units left of the origin. It does not say at what time does that happen, so I guess I can leave that out. But yeah, that is the greatest distance. Let's check our scoring guidelines and just see, since I assume I have them in here. Yeah. All right, so 1.587, I honestly can't remember what I got for that. 1.588 because of rounding there. And then the other answer, so that's fine, 1.588. The other answer says, yep, okay, v of 2 is less than 0. So you need to say speed is decreasing, which we did with reason. That was our reason. Again, you can have the decimal version. So when they say you get a point for t equals square root of 2 pi, it would be silly to algebraically find that answer. Just do what we did and go ahead and calculate to find that time using the graph is what we did. All right, and then justification. I just have, they really went into this. I just said that the particle changes directions because of velocity change signs, which is what this said, right? Maybe I should have said change signs at 2.506 or 507, but either way, I think that's okay. Part C is 3 points, but look at how short the answer is. You get 1 point just for writing 0 to 3. That's what it means by limits. 1 point for the integrand. Make sure that you include dt. If you're not writing that, I'm not giving you a point for the integrand because it's not right. You have to have the absolute value as well. And then, of course, your answer. And see how they have, so this is where, yes, I was correct to use the non-rounded version here because they had the exact value of square root of 2 pi, whereas I had the, whatever it was, 2 point blah, blah, blah. So yeah, so it's good to use the non-rounded there. And you get 1 point for, it says distance particle travels while velocity is negative. You don't have to figure that out separately because you can just put, oh wait, sorry, I'm thinking of the total distance, because I just did my absolute value around that, so I didn't have to worry about where it changes directions. Answer, ultimately we got this negative 2.265, and that was considering, so with our candidates we considered 0, 3, and this square root of 2 pi. We had the decimal version of that, so we're considering where the velocity, how far it traveled when it was negative. That's what it means by that. Sorry. And then my answer, yes, was that ultimate value of 4.334 for our final answer. So it's good to look at the scoring guidelines and sort of say, like, did I have anything? Did I write my answer differently? And if I did, which is very likely that I wrote it slightly differently, did I come to the same conclusion? So that's the important part too. All right, that finishes the first packet.